Welcome to a complete end-to-end video where we can build and host our own production-grade AI chatbot, Agentic chatbot. This is the full video. Individual sections of this video was already published. This is for your convenience. I have assembled all those videos together as a single video for your easy reference. We are not making a chatbot. We are building and hosting a production-grade AI chatbot, end-to-end. So it is fast, secure, observable, and resilient. If you have seen demos that stop at it runs on my laptop, this is the opposite. By the end, you will have something you can deploy, scale, and trust. Here is the roadmap we will follow step by step. First, environment setup. We start by locking down the environment, consistent runtimes, pin dependencies, .env management, and reproducible dev and production parity. Why this is significant? It kills work on my machine bugs and makes rollback safe. What is unique here? We treat the environment as code, scripts you can replay, not a checklist you will forget. Production and resilience, deterministic builds, health checks from day one, and version config so you can recover instantly. Next, a static web app that hosts your front end. Remember, if when you go live, you will already have a website, so you can replace this with your website. This is significant because this static CDN based hosting gives you global speed, simple scaling, and fewer moving parts. We design it for zero trust from start, no secrets in the browser, and clean separation from the API. Production and resilience, immutable deploys, cache busting, and rollbacks in seconds if anything breaks. We will stand up an echo chatbot first. Just request in, request out. Significance, a tiny testable baseline that proves our contracts, latency budgets, and logging pipeline. Unique, we will include structured logs and trace IDs even in this toy, so defects are visible early on. Production and resilience, timeouts, retries with backoff, and graceful error messages by default. Then we level up to an agentic system. Tools, function calling, multi-step reasoning. Significance, this is how you go from chat to work. Calling APIs, using skills, orchestrating tasks. Unique, we constrain the agent with guardrails, schemas, and safe tool contracts. Useful power without chaos. Production and resilience, deterministic tool routing, fallbacks to simpler prompts if tools fail, and circuit breakers to prevent runaway loops. Next, we will add web access, controlled external lookup for fresh, real-world answers. Significance, your bot stops hallucinating stale facts and becomes timely and useful. Unique, we sandbox IO and log every fetch so that you can audit sources and block risky domains. Production and resilience, strict timeouts, content size caps, and degrade gracefully when the web is slow or down. Now RAG, retrieval augmented generation, with the vector knowledge base. Significance, your chatbot speaks with your docs, your policies, your product truth. Unique, we show trunking strategy, embeddings hygiene, and evaluation, so recall and precision are measurable. Production and resilience, warm indexes, background refresh jobs, and safe fallback when retrieval returns nothing. Locking in cords, who can talk to your API from the browser? Significance, this is the line between your backend and the entire internet. Unique, we whitelist origins by environment and teach how to test misconfigurations quickly. Production and resilience, perfect caching, strict methods and headers, and deny by default so mistakes don't leak data. Next, we protect tokens and secrets the right way. Significance, one leaked key can burn the budget and data. Unique, we separate client and server capabilities, use short-lived tokens, and rotate keys without downtime. Protection and resilience, vault-backed storage, least privilege, and kill switches if compromise is suspected. And then rate limiting to control cost and defend against abuse. Significance, protects your wallet, your users, and your uptime from spikes and bots. Unique, we combine per IP, per user, and per route limits with sliding windows that feel fair. Production and resilience, HTTP 429 responses, hint headers, and exponential backups so clients recover smoothly. Finally, a watchdog, health checks, alert, and auto recovery. Significance, if you can't see it, you can't trust it. We will monitor latency, errors, cost, and token usage. Unique, we wire alerts to actionable signals, not noise. Budget thresholds, unusual prompt lengths, and tool failure spikes. Production and resilience, restarts on crash, traffic shedding under pressure, and dashboards that prove SLOs. That is the journey from setup to a resilient, secure, cost-aware chatbot that is ready for real users. So clone the repo and let's ship something you would be proud to run in production. Let's get started. First, the environment setup. Welcome to our first lesson. Today we are kicking things off first by setting up a basic environment for our chatbot. We will use Docker to create a simple web server that says, "Hello world." This is the foundational step for everything that follows. Let's dive in. So let's look at the file, docker compose.yaml file. So here is the docker compose.yaml. We have one service defined here, and we call the service front end. This tells Docker Compose to look inside the front end directory to find the instructions for building our front end container. It's looking for a file named Docker file. And we are mapping port 8080 of the host machine to the container's port 80. So when we open our web browser to localhost 8080, it will connect to Nginx web server running inside the Docker container. And we are mapping the front end folder to the document root of the Nginx web server, that is /user share Nginx HTML. So this is a live sync. So any change that happens in the front end will be reflected in the container live. There is no need to rebuild the container when we map the folder like this. Now let's look at the Docker file in the front end folder. So first line, from Nginx Alpine. This tells Docker to use the official Nginx Alpine image as our starting point. Nginx is a high performance web server and Alpine is a very small security focused Linux distribution. And this keeps our image lean. And copy /user share Nginx HTML. This line copies all the files from our local front-end directory, in this case just the HTML from the front-end folder, into the document root, that is user share Nginx HTML, which is inside the container. This is where Nginx is looking for files to serve. And expose 80, this is just for documentation. It tells that the container listens to port 80. And this is what we are mapping to host machines port 8080. We also have another file, index.html, in the front end folder. This is the actual web server of the application. In this case, it is a sample placeholder website. This is an elementary website, standard HTML file with a title and a hello world message. So how do we get this all running? Remember, the code is, the URL to the GitHub repo is given in the description. You need to clone it to get this folder. Let me come to the terminal. This is the folder 01env setup. In this folder, we run the command docker compose up. We can also type up -d to run the container in the background, but since this is a demo, I'm running it in the front end. Okay, so this starts the Nginx web server, mapping the front end folder to the document root. Okay, it's running. So now, which port we should browse? It is 8080. Here we have the sample hello world web page, and this is being served from this index.html. See here, hello world. If we edit this page and save it, we can refresh and see the changes immediately. So this makes the development easy. So this is the first step where we have, so the command that we typed is docker compose up, which will start the building of the image from the front-end folder using the Docker file, and then start the container defined in our docker compose.yaml. And once it is running, we can open localhost colon 8080. To conclude this first exercise, we have defined a simple web service in the Docker Compose YAML, created a Docker file to build a custom Nginx image, and served a basic index.html file. This setup is the first building block of our chatbot application. In the next session, we will build on this foundation. See you there. A static website. Welcome back. In our last session, we set up a basic Hello World page. Now what we're going to do is, we're going to take a major leap forward and transform the simple Hello World web page into a beautiful, modern, fully designed static website. So remember, this website is a demo website so that we can add our chatbot to this website. So this static website is a fictional furniture company called Sofa and Company. This will form a visual foundation for our chatbot. Let's get started. So there is no change in the infrastructure. First off, let's be clear about what hasn't changed. So the docker compose.yaml and the Docker file are identical to our previous exercise. So the underlying setup is simple as an Nginx web server. We are not changing the infrastructure, just the content it serves. This is a great example of how you can separate your application's environment from its content. So we have a new index.html. So if you see this, so this is the furniture company's website. We also have the corresponding style.css, which is added to this index.html page. So I'm in the folder where we have the docker compose.yaml for this exercise. And I'm going to type docker compose up to serve the web server. So now if you come back to localhost 8080, which we saw in the previous section, if you refresh this page, you will see a nice looking placeholder website for the furniture company, Sofa and Company. See this? There is no chatbot. So where is this web page being served? It is served through this front-end folder, the container that is running the Nginx web server. It is serving this index.html, and this index.html has the style.css linked. That is why we see this. So with the same simple Docker setup, we have gone from a blank Hello World web page to a rich, visually appealing website. We have introduced a structured HTML document and a comprehensive CSS file to create a modern-looking website. This static site is the perfect front-end for the chatbot we are about to build. In the next session, we will finally add the chatbot itself. See you then. A simple echo chatbot. Welcome back. Now that we have a beautiful website, it's time to make it interactive. In this lesson, we are going to introduce a backend service and connecting it to our front end to create our very first basic chatbot. It is going to be a simple echo chatbot. Whatever you type, it will say hello and repeat it back. This is a huge step because it lays the groundwork for all the intelligent features which we'll be adding later. Let's dive in. Let's look at the docker compose.yaml. So this docker compose.yaml has changed. It now has a backend section mapping to backend folder, and it is using host port 8001. And inside this container, our Python application will be running and listening to port 8000. We are also mounting 2 volumes which are being used by the container. The command starts our Python application using uvcon, a lightning fast web server. It tells uvcon to run the app object from the main.py. Now let's look at our backend. Backend has got the Docker file. This is a standard Python Docker file. It starts from Python 3.9 image, copies our requirements.txt, install the dependencies using pip, and then copies our application code. Requirements.txt has got fast API uvcon.env module of Python, and Pydantic library. We will see why we need these. In the app folder, we have the main application, which is the Python application. Here we are creating the Fast API app and adding the CORS middleware. We will talk about these CORS later when we address security issues. Without this CORS middleware, our server will block access to a different port address. In this case, 8001. We define here a simple endpoint /chat. So whenever we call this endpoint, this function will get activated, and the message that we pass to this /chat endpoint will be fetched using body.get. So request.json is what is filling this body, and then body.get message is the name of the message that we type, and what we return is hello and then the message that we type. That is it. Here we are using streaming response to respond back to the front end. And what are the changes in the front end? Let's look at the index.html. There we will have the chat container here and the chat icon, and then chatbot.js is included. So that chatbot.js contains our chatbot's front end. Okay, so if you look at the chatbot.js, here we have the chatbot code. That is what is interacting with the user and passing the messages to the backend. So here in the index.html, we are also defining the backend URL, which is localhost 8001. That is where our Python application is serving the endpoint. So let's start the application like before. Docker compose up. Okay, our application is ready. Let's browse it. Let's refresh it. If everything is okay, we'll see our chatbot icon. See, we have the chatbot. If you type your name, for example, it will say hello Sri. So this is a neat looking chatbot interface, but this is a basic chatbot. It has no backend functionality to talk to a large language model, etc. Those are the ones that we are going to add in subsequent videos. Instead of making the video very large, we will stop this video here, and in the second video, we will convert this into a functional chatbot with an agentic LLM added and also RAG added, making it an AI agentic chatbot. Welcome back. So far, we have a beautiful front end and a back end that can echo messages. Now it's time for the magic. In this lesson, we're going to replace our simple echo logic with a powerful large language model from OpenAI. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. We will be using Agnos library, Agentic framework, a fantastic tool that simplifies working with large language models to turn your chatbot from a simple parrot into a true conversational AI agent. This is the moment it all comes to life. Let's get started. So let's look at the new main.py, the backend script. Here we have the main.py, the new backend script, and all these are imports. Okay. We also have this .env, load.env imported and executed here. So what this will do is, this will use .env file that you see here and load the API keys from it into the application as variables. I have placed a placeholder prompt which you can ignore, but you can use this as a template when you build your own customized chatbot, so that you don't miss any of these important points. Now, this is the main part where we define the agent. So remember, this chatbot is an agentic chatbot, which is more sophisticated. It's able to do much more than a simple LLM API communication. And here we define the model. I'm using GPT-4o mini, but you can choose anything. You can even run a small Olama model on your hosting machine. Here we have the instructions. This is very simple, tiny instruction for clarity. And we are mentioning add history to messages. This will ensure that the chatbot remembers previous conversations. We are limiting the number of history items to 3. Now the next change is in the chat endpoint. Remember, our front end is communicating to this endpoint. Earlier, we were just echoing back, appending a string hello. In this case, we are defining an async function generate, which is what is going to talk to the agent and get the response. And we are responding back in a streaming fashion. Where is the agent execution with our query? This is where our query is. This is what is executing the agent. The agent is what is going to talk to the large language model. That is it. So let's run and see. I'm in the Agentic Chatbot folder. There we have these files, Docker Compose YAML file, the backend and the front end. And those folders have these files. And remember, the code is there in the description. You can download and use it. And how do we start? Docker Compose up. And in production, you will also give -d so that it runs in the background. So we will see all those aspects in the coming videos. Okay, the application is started. Let's reload the page. And here is our placeholder Sofa and Company website. Let's click the chat icon. No visible change, but now it is not just echoing, it is able to intelligently respond like a ChatGPT. Please add 2 and 3. One I'm giving as a number and other as text. See? And let's see if it can remember. Can you add one more to it? Yes, it's able to track the conversation history. So this is a huge milestone. We have successfully integrated a large language model to our application, and we saw how to securely add API keys using the .env file and how to use the powerful Agno agentic framework. The foundation is now set. In the next lessons, we'll build on this by giving our agent access to tools, long-term memory, and more. See you there. Allowing web access through the chatbot. Hello and welcome back. Our chatbot is now intelligent thanks to the agentic framework that we have added in the previous video. If you haven't watched, please remember to watch it. But it has a limitation. Its knowledge is frozen in time based on when its model was trained. To make it truly powerful, we need to give it access to live internet. Remember, you add this only if your chatbot needs this feature. But let's see how to do it. In this lesson, we will do exactly that. We are going to give our agent the ability to search the web, making it smarter and more capable than ever before. Let's get to it. We will only be looking at the changes so that we can keep the video short and to the point. Remember, the code is accessible to you and the link is in the description. So here we have the backend, and in the app folder we have the main script, which is main.py. So let's come to the addition. This is where we are importing the tool DuckDuckGo tools. Now this DuckDuckGo tools will allow us to access the web to get the up-to-date information. Where do we use it? If you scroll down, where we define the agent, see here, we have added the new line, tools equal to DuckDuckGo tools. And the agentic framework is what is allowing us to access these tools. Without agent, we would have had to code this manually. This agentic framework makes it very, very easy to add tools. There can be multiple tools. If you have a booking tool, you can add it here, which we have covered in one of our previous videos, but subsequent videos, we will cover those items also in this modern agentic chatbot. Let's see this in action. So Docker Compose up from the folder, and the folder should be this, where you have the backend, front-end folders, and docker compose.yaml file. Remember, we have the hidden .env as well. We should have the API keys. So docker compose up. Okay, application is started. Let's visit the browser and refresh the page. Can you search the web and find me top 3 sofa models? Let's see what it does. Okay, see here, drifting wood, wooden sofa set from Hokibo, sofa sets on Amazon. So this is from the web. This is not in our local. We haven't added anything related to this in our AI chatbot. But in the next video, we will see how to add our own custom knowledge into our chatbot. Our chatbot is no longer confined to its initial training data. It can now access the vast live database of the internet to answer a much wider range of questions. By simply adding a pre-built tool to our agent, we have dramatically increased its power and utility. In our next session, we will explore another powerful feature, giving our chatbot a long-term memory using a vector database. See you there. Adding RAG knowledge base to the chatbot. Welcome back. Our chatbot agent can now browse the web, which is incredible. But what if we wanted to be an expert in our private data? Things like internal company documents, our products, specific product manuals, or in our case, our furniture products. That is where retrieval augmented generation, or RAG, R-A-G, comes in. Today, we are giving our chatbot a long-term memory by creating vector knowledge base, turning it into from a generalist to a specialist. Let's begin. So what is RAG? It is a powerful technique. We take our private data documents, chop them into small pieces, and use an AI model to turn each piece into a list of numbers. These are called vector embedding. These vectors represent the meaning of the text. We store all these vectors in a special database called vector database. When a user asks a question, we first search this database to find the most relevant chunks of text from our documents. Then we augment the prompt by stuffing that relevant text into the context window before sending it to the AI. This way, the AI has the exact information it needs to answer questions about our private data without ever being trained on it. Like before, the changes are in the main.py. Let's look at the script and see the changes. So this is the folder, and that folder is called 06 RAG Vector Knowledge Base. It will have a backend folder and a front-end folder. Remember, the code is given in the description. The link is in the description. This .env file should have the API keys for the model that you are using. And there is no change in the Docker Compose. There is no change anywhere except the backend app main.py. Now here, we are creating a very powerful, flexible RAG. We are importing Agno's feature of being able to combine multiple types of RAG, because the RAG can come in the form of PDF documents, in the form of text files, in the form of website URLs. All these can be combined together into a single vector database. That is the beauty of this demo. So here we are importing the library. Here we are importing a CSV knowledge base. In case we have a text-based knowledge base, we can place it here. You place all those text files in this data CSVS folder. Okay. We are not adding anything. If you add, it will get automatically included in the vector database. Then we have a PDF included, a URL to Thai recipes, which has nothing to do with our sofa company, but this is just a placeholder so that you know how to add a PDF document. Then comes website knowledge base, where I have created a dummy sofa company knowledge base. That is what I will demonstrate. And then here we have a local PDF knowledge base as well. Just put your local PDF documents into this folder. And this is the beauty. This knowledge base, combined knowledge base library of Agno will allow us to create a single knowledge base from all these individual different types of knowledge entities. And then this is where we create the vector database. We are using LanceDB, and you have the freedom to choose any other vector database. Like here, I'm commenting out the Postgre vector database. Then comes the final change. That is, here we are adding the line knowledge equal to the combined knowledge object that we have just created above. So that is it. So let's see this in action. I'm in the correct folder, Docker Compose up, and see, it's loading the knowledge base. Let's refresh. And here we have, say, let me ask about this. Can you tell me more about the minimalist sofa? Okay, so here, the minimalist sofa. See, remember, this information is coming from the knowledge base, our own private data. If we ask, do you have a parking facility? See, yes, our showroom for the furniture products offers parking facility. See this? Beautiful, isn't it? This is the power of RAG. We have created a true expert system. Our chatbot now has a secure, private, long-term memory that we can fill with any document that we want. It's a massive leap in capability. In our next lesson, we'll focus on securing our application by implementing CORS and other security best practices. See you there. Securing chatbot using CORS security. Hi everyone, we have built an incredibly powerful chatbot, but with great power comes with great responsibility. Right now our chatbot is wide open. Any website on the internet could potentially embed our chatbot and make requests to your backend, which could lead to unauthorized use and a huge bill. Today we are going to lock it down. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. We will implement a crucial security feature called CORS, Cross-Origin Resource Sharing, CORS, to ensure that only your website can talk to your backend. Let's get secure. What is CORS? CORS is a security mechanism that browsers use. By default, a web page on a domain like a sofaandco.com is not allowed to make requests to a server at a different domain like api.mychatbot.com, etc. This is called same origin policy. It prevents malicious scripts from making unauthorized requests. CORS allows servers to relax this policy. A server can tell the browser, this is okay, I just trust that other website. You can allow its requests. We are going to configure our backend to say that it only trusts your own front end. Let's look at the backend and see how we can implement CORS. Here I am in the folder 07, CORS security. Remember, the entire code of this and the previous videos are available in the repo. If you see, you will have the backend, dockercompose.yaml, and the front end. We have also added a README for you to know the contents of this folder. To bring up the application, what we need to do is docker space compose space up. Okay, application is ready. Let's refresh. There is no visible change. We are not expecting any visible change. Only thing is this code is now secure so that other websites, other domains cannot embed our chatbot code into their website. For example, if somebody wants to steal our code, they would look at the view source and copy this section where we are including our JavaScript. Just copy this and paste it into their website and it will allow the chatbot to be embedded there. That is what we are preventing. So this is the folder, and in the app we have the main. Here we are defining a variable origins, which is a list, and there we will add the domain names that are allowed to talk to our chatbot's backend. That is it. After that, this list we place here so that it will only allow requests to come from these domains. So in order to see this in action, what we will do is we will comment these out. Okay, and let's restart our application. Let me refresh. Yes, it seems to be working. Is it working? Let's see. Can you add 2 and 3? See, I am having trouble connecting. Please check your internet connection again. And if you view inspect, if you see failed to load resource, the server responded, access to fetch this localhost colon 8001 has been blocked, It is also giving us the suggestion what to do. So let's close this and uncomment those 2 lines to allow the localhost domain and restart the application. Can you add 2 and 3? See, the error is gone. Okay, so that is how we include. So this variable fast API app add middleware is what is including the allowed origin. That is it. No other change in the script. Security is not an afterthought. It is a critical part of building any application. By changing just a few lines of code, we have made our chatbot significantly more secure. We have restricted access to our chatbot backend, ensuring that only our approved frontend can interact with it. In the next lesson, we will add another layer of security, implementing session-based token security. See you there. Adding token security. Hello and welcome back. We have made our chatbot safer by implementing core security in the last video, which is a great first step. But CORS only protects us from other websites. It doesn't stop a savvy user from using a tool like curl or any other command line access tool to make requests directly to our chatbot's backend API. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. Bypassing our website entirely. To truly secure our chatbot, we need to make sure that every request comes from legitimate authorized instance of our chatbot client or frontend. Today, we are adding our second layer of security, token-based session security. Let's get started. So the strategy is adding session tokens. So here is the plan. 1, when our chatbot first loads the frontend, it will make a request to a special endpoint on our backend to ask for a session token. 2, the backend will generate a unique random token like a ticket for a movie and send it back. It will also remember that it gave out this token. From then on, every single message the chatbot sends to the chatbot backend endpoint, it will include this special token in the request headers. 4, the backend will check the token on every request. If the token is valid and one that it remembers, it will process the request. If the token is missing or invalid, it rejects the request with an unauthorized error. This ensures that only clients who have first properly initiated a session can use the chat service. Clear? So let's look at the main.py, which is our backend script, the new endpoint. So I'm in the folder 08 token security. And remember, this code and the code for all our previous videos are available in the description. The GitHub repo link is given. So here we have the folder And let's look at the backend app main.py. And if you scroll down, you will see the new endpoint /session. And here we have the function that creates the session and returns the session ID. And I can browse this directly and show you the session ID being returned. So I'm giving you the command here itself for reference. So let me open a new terminal window, and the other window, let's start the application. Okay, application is up. From here, if you curl, which is the command line utility to access endpoints, if you call the session endpoint, see here, we have the session ID returned. So this token is what our backend will be expecting for all requests. Remember, if there are multiple requests from different clients, it will of course maintain multiple session tokens. Let's come back to this code. There is a change, and there is one change in the front end. So if you look at the index.html, see here, there is a get session function added to our front-end chatbot JavaScript code, which gets the session and saves the session ID. Next change is in the backend. If you search for session ID, so here this get session ID function is called whenever there is a chat request. See here, this chat endpoint has been modified, and we are saying it depends on get session ID. If that returns true, then only we'll proceed. Otherwise, we'll abort the call from here itself. That is the change. Code and the explanation README is provided for you in the description. Here, if I change the session ID to a dummy value and refresh, can you see here? I'm having trouble connecting. It's returning an error. Let's remove this line and reload. Can you add 2 and 3? See, the error is gone. We have now gone beyond simple domain level protection, but implementing a session token protection. We are ensuring that every request to our chatbot service is authorized and comes from a legitimate client instance. This is a critical step in building a secure and robust backend API. In our next lesson, we will tackle another form of abuse, users sending too many requests. We will implement rate limiting. See you there. Adding rate limit. Welcome back. Our chatbot is secure and powerful, but there is one more threat we need to address. That is abuse. A single user, whether malicious or just over-enthusiastic, could send thousands of requests to our API backend in a short time. This can overload our server, rack up huge API costs, and degrade the service for everyone else. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. Today, we are implementing rate limiting, a crucial defense to ensure our chatbot remains stable and available for all users. Let's get started. So what is rate limiting? Rate limiting is a technique to control the amount of traffic a user can send to an API in a given time window. For example, we say each user is allowed only to send 5 requests per minute. If they exceed this limit, we temporarily block them and tell them to slow down. This prevents a single user from overwhelming the system and ensure fair usage. For this, only change needed is in the backend. So let's see the code. We are including the Slow API library here, and we start by creating the limiter object. Here we have the limiter object created, and we are using the IP address to identify the client. If we come down in the middleware, we are adding this line where we include the limiter also to the middleware. That is it. After this, every endpoint that you want to restrict, for instance, the chat endpoint, we are limiting by adding this so that only 5 requests per minute is allowed. So let's see it's working. Let's start the application. Okay, application is ready. Let's reload. Can you add 2 and 2? Add 3 more. Add 4 more. Okay, that also worked. Add 3 more. That also worked. Add 5 more. That also worked. Add 3 more. See here, I'm getting a lot of requests right now. Please try again after a moment. We have limited 5 requests per minute. And if you see the backend, you will see that we're getting HTTP 429, too many requests. We will look at the steps involved. First, rate limiting is an essential tool for building robust, scalable applications. With just one new library and few lines of code, we have protected our server from being overwhelmed, controlled our potential API costs, and ensure fair and stable experience for all our users. This is the end-to-end first video. Subsequent videos, we will add various aspects that we discussed in this. Instead of making a very long single video, next video in this series will cover additional aspects we have been addressed in this one. Thank you for your time. See you. Bye-bye. Thanks for watching. Please like, share and subscribe. Your support really helps. Have ideas or suggestions? Drop them in the comments. Let's build together. At Shogini, we offer expert nocodemake.com and Python AI automation consulting with ready-to-use modules to jumpstart your projects. Stay tuned and subscribe for more.